Let's read it. We have triangle ABC with R on side AB. We're given two sides as vectors and the ratio for a R. We'll describe some vectors, then work with their lengths. Here's what we're given. The two sides as vectors, and R is 2/5 of the whole side AB. And the goal, write A, B, and C, R using U and V. Find the length of C, R, then the shortest distance from it to the line C, R. So, to summarize what we have and what we're after. Two sides as vectors plus the ratio for a R. From those we build the vectors, their length, and the distance. Picture the triangle. C at the bottom left, B at the bottom right, A on top. Here's the key idea for vectors. To add two of them, lay them tail to head. From A we hop to C, then C to B. The single arrow straight from A to B is the sum, so A, B is A, C plus C, B. That's the triangle law. And reversing an arrow flips its sign, which we'll use in a moment. Now the two given vectors, drawn out of C. C to A is 5V, and C to B is 6U. The arrowheads show which way each one points, and that's what decides the signs. R sits on A, B, 2/5 of the way from A to B. Let's keep the diagram beside us and work through it. Part A1, we want A, B in terms of U and V. We use the triangle law. Hop from A to B through C. A, B is A, C plus C, B. Going A to C is the reverse of C to A, so it becomes minus C, A. Swap in the given vectors. Tidy it up, and A, B is 6U minus 5V. Part A2, now we want CR. CR runs from C up to R. To get there, go C to A, then A to R, tail to head. AR is 2/5 of a B, and we just found AB, so put that in. Multiply both terms by 2/5. Now C, R is C to A plus A to R. C to A is 5V, then add what we just got. Combine the V terms, and C, R is 12/5 U plus 3V. Part B1. Now U and V are actual vectors, so let's find the length of C, R. Take our C, R, and swap in U equals 5I and V equals I plus 4J. Work out each piece and collect them, 15I plus 12J. The length comes from the components, just like Pythagoras. Square the components, add them, and we get the root of 369. That simplifies to 3 root 41, about 19.21 units. Part B2. This is where the line PQ comes in. P is on C, A, Q is on C, R, and P. Q is parallel to AR. Q splits C, R went to 2, so C, Q is 1/3 of the whole C, R. Because Q is parallel to A, R, and they share the angle at C, the small triangle C, P, Q is similar to the big triangle C, AR. Enlarge a shape, and its area grows by the square of the scale factor. The scale factor from the small triangle to the big one is 3, so its area is 3 squared times the small area. That gives 120. A common slip is to scale by 3 instead of 9, so remember it's the square of the scale factor. Now the shortest distance from it to the line C, R, which is the perpendicular height. Drop a perpendicular from it onto C, R. Its length is the distance we want, call it H. The area of a triangle is half the base times the height. Use triangle C, A, R with base C, R and height H. We know the area is 120 and the base is 3√41, so put those in. Rearrange for H. Rationalize the surd, and the shortest distance is 80√41 over 41, about 12.49 units. Final answers. A, B is 6u minus 5v. C, R is 12/5 u plus 3v. The length of C, R is 3√41, about 19.21 units. And the shortest distance from it to C, R is 80√41 over 41, about 12.49 units.